This is SpaceTime Series 27, Episode 100, for broadcast on the 19th of August 2024. Coming up on SpaceTime, the origins of Stonehenge's altar stone revealed, NASA's Mars Perseverance rover begins the long climb up Jezero crater's rim, and tomorrow's full moon, it'll be a blue supermoon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
It's long been considered an ancient astronomical calendar, and now new research has revealed Stonehenge's monumental 6-ton altar stone, long believed to have originated in Wales, actually comes from Scotland. The findings, reported in the journal Nature, show just how connected and advanced Neolithic Britain was 5,000 years ago. The distance between Stonehenge and the far north of Scotland is around 750 kilometres. The discovery of the altar stone's real origins was made by scientists at Curtin University, who were sent fragments of the mostly buried 5 by 1 metre wide 50 centimetre thick boulder, which lies at the centre of Stonehenge's iconic stone circle on Salisbury Plain in southwestern England. The analysis shows that the altar stone matched sandstone from northeastern Scotland, and was very clearly different from the Welsh Brecon Beacons or Black Mountains regions where it was originally assumed to have come from. Stonehenge, specifically the Great Trilithon, the encompassing horseshoe arrangement of the 5 central trilithons, the hill stone, and the embanked avenue, are all aligned to the sunset of the winter solstice and oppose the sunrise of the summer solstice. A natural landform at the monument's location followed this line and may have inspired its construction. The excavated remains of culled animal bones suggest that people probably gathered at the site for the winter solstice rather than the summer solstice in order to participate in religious ceremonies and festivals. In the 1960s, Gerald Hawkins described in detail how the site was apparently set out to observe the sun and moon over a recurring 56-year cycle, further cementing the hypothesis that the monument functioned as an astronomical calendar. The ancient monument consists of an outer ring of vertical sarsen standing stones, each around 4 metres high, 2.1 metres wide, and weighing around 25 tonnes, and topped by connecting horizontal lintel stones. Inside is a ring of smaller blue stones, and inside these are freestanding trilithons, as well as 2 bulky vertical sarsens joined by a lintel. The stones are set within earthworks in the middle of the densest complex of Neolithic and Bronze monuments in England, including several hundred burial mounds. Archaeologists believe Stonehenge was constructed in several phases, from around 3100 BCE to 1600 BCE, with a circle of large sarsen stones placed between 2600 BCE and 2400 BCE. The surrounding circular earth bank and ditch, which constitute the earliest phases of the monument, have been dated to around 3100 BCE. Radiocarbon dating suggested the blue stones were given their current positions between 2400 and 2200 BCE, although they may have been at the site much earlier, possibly as early as 3000 BCE. Previous studies have shown that Stonehenge's large sarsen stones, which form all 15 of the Henge's central horseshoe, came from the nearby West Woods on the edge of Wiltshire's Marlborough Downs. These include the uprights and lintels of the outer circle, as well as the outlying stones such as the heel stone, the slaughter stone, and the station stones. Stonehenge's blue stones, on the other hand, originated from Pembrokeshire in Wales. They were originally erected at Stonehenge in an arc of double stone holes known as the Q&R holes, before being rearranged into their current arrangement of outer circle and inner horseshoe. One of the study's authors, Professor Chris Kirkland from Curtin University, says the findings of the true origins of the altar stone have significant implications for understanding ancient communities, their connections, and their transportation methods. He says the discovery highlights a significant level of societal coordination during the Neolithic period and helps paint a fascinating picture of prehistoric Britain. Kirkland believes transporting such massive cargo overland from Scotland to southern England would have been extremely challenging, suggesting instead a likely maritime shipping route along the coast of Britain.
So the central stone within Stonehenge is the altar stone, and it's a flat-lying 6-ton monolith. And we've been lucky enough to get historical samples from that, and using some technology we've developed at Curtin for the mining industry, using geochronology to looking at the age of the crystals, we've been able to give a very distinct fingerprint for that altar stone. And by comparing that to sandstones around Britain and Ireland, we've got a very good match with material from northeast Scotland, and at greater than 95% confidence, we can say that the altar stone has come from 750 kilometres away in the Acadian Basin.
There must be a lot of sandstones in the British Isles. Would have been a tedious trial and error job.
Yeah, well, but that's the thing with sandstones, right? A sandstone collects lots of grains from the surrounding geology, so it gets actually a very distinct fingerprint. So the sandstones will basically collect grains from the surrounding granite and mountain ranges, so it imparts this almost unique fingerprint into the basin where the sediment is. Luckily, within the UK, there's actually been quite a lot of work already done looking at sandstones. So by collecting new samples, but also using this huge database of published results from sandstone samples, we were able to make some very good correlations. The other important point as well is that the British Isles has got a very distinct geological history. North of, a join between Scotland and England, the geology is very different. So by looking at the ages within our grains, we can already narrow down very quickly where the material has come from.
Were you surprised to see that it was Scottish, not Welsh?
Yeah, to be honest, I was shocked. It's already a massive task importing material from Wales to Stonehenge, because we know some of the other bluestones, so bluestones are the more exotic, far-travelled rocks, came from hills within Wales, about 200 kilometres away. That's already a huge task. But just spare thought for these guys in the Neolithic now, carting material, 6-ton rocks over 750 kilometres, and that really helps us understand prehistoric society, Neolithic society in the British Isles, how connected they were, and also helps us understand some of their technology.
Well, that's the thing, isn't it? It shows that what we now call the UK was really well connected long, long ago.
Yeah, that is absolutely correct. That's really strongly what it points to. It's a really fascinating story, but it's not without precedent. We have some other evidence, for example, of cattle and other materials being transported over sea voyages to northeast, northern the UK now in the Neolithic period, but this just shows how advanced that technology was, that it was able to transport material as large as 6.5 tons. I guess one thing I like to say is, just even today, transporting a 6.5 ton rock from Scotland all the way to England would be a massive.
I can imagine that. What we now call the British Isles would have been a heavily forested area back then, and to have this piece of rock transported such a great distance, you couldn't do it overland. It had to be by sea, surely.
Yeah, I absolutely agree with you. You think about it, you're right. The vegetation was very different back then, much more heavily forested, but also there's huge mountain ranges, valleys, there's bogs, there's estuaries that would all have to be navigated if it came an overland route. So our preference at the minute, based on the evidence we have, is that it is come via submarine shipping route. We should also say that we also considered glacial transport, but that really doesn't work either. While the UK has been heavily glaciated in the past, if we look at the glacial flow directions, they're all in a very different direction, all actually northwards and taking things further away from the Acadian Basin. That's that basin in northeast Scotland where the material has come from, and Stonehenge in the south of England. Also, none of the rocks really within Stonehenge have glacial striations, and if we look at more collectively all the rocks at Stonehenge, they appear to have been chosen from very specific regions, so it's not this random collection of material that you might expect if material had been glacially transported.
Have you drawn an opinion yet as to what you think Stonehenge was used for?
The function of Stonehenge, I think we can say some things quite safely. We can say that it hasn't been used just for one thing. It has solar alignment. There's elements that might have lunar alignment, so there is some aspect of it being a calendar. That's one important thing. But we also know there's burial grounds there as well. So there's probably multiple purposes here. We know there's also feasting at Stonehenge. So really this may have been used for different things at different periods of time. One thing is for sure that the society really invested a huge amount of effort in constructing it. So it was obviously somewhere very important and sacred to them.
And it was constructed over many, many, many hundreds of years with different rocks coming from different locations.
Yeah, that's absolutely right. we know that in some of the later construction phases, there's the large sarsen stones, which are from the local environment about 20 kilometres away. We've mentioned already the blue stones, which are smaller stones erected in circles, which have come from Wales. We now know the central 6-ton flat-lying slab, the altar stone, a sandstone, is from northeast Scotland, but there is historical evidence of wooden circular pillars as well. So it's had a huge history of construction and indeed probably reconstruction in places as well. So there's evidence of some of the monoliths, so the standing stones actually have been moved from elsewhere, from potentially other stone circles. So it's a fascinating history within the structure itself.
Where does this go now? What's next?
I think there's multiple ways the research could go. We're kind of keen to look at northeast Scotland and really pin down exactly where within the Acadian Basin the actual quarry itself is. And there's ways we can do that because the kind of fingerprint within the basin is quite distinctive, but we can look at a range of other mineral grains to try and really fine-tune our understanding of the geology of the source region, which would be really interesting. But I guess more broadly, it's really fun for us as geologists and geochronologists who work at the age of rocks to apply this tool that we normally apply to the mining industry to apply it to other archaeological questions. And there's a range of other sample material that we could actually apply the same technique to.
What you've actually done here is change history. You've exposed a new page in the history of Stonehenge. How does that make you feel?
It's incredibly exciting, but also quite privileged to have the tools. Also, I should mention my PhD student, Anthony Clark, as well. His inspiration to actually go and select this material. So it's Welsh, serendipity, I think. You've got... he's Welsh. So
he's okay
people make a joke
discovery?
about, that's what everyone has. So I think his response is usually around the rugby, where he points out that, it's okay. As long as Wales win the rugby, it'll be all right.
That's Professor Chris Kirkland from Curtin University. And this is SpaceTime. Still to come, Perseverance begins its long climb up to the rim of Jezero crater, and we're in for not just a supermoon tomorrow night, it'll also be a blue moon. We'll tell you all about it. All that and more still to come on SpaceTime. After spending some 2.5 years exploring Jezero crater's floor and river delta, NASA's Mars Perseverance rover has now commenced its journey to an area where it will search for what hopefully will be more discoveries that could rewrite Martian history. The 6-wheeled car-sized mobile laboratory has just begun a multi-month-long ascent up the western rim of Jezero crater, and that'll see it tackle some of the steepest and most challenging terrain it's ever encountered. The climb will mark the kickoff of the mission's new science campaign, its 5th since landing on the red planet way back on February the 18th, 2021. Perseverance has now collected some 22 rock cores and travelled over 129 kilometres since arriving at Mars. Perseverance project manager Art Thompson from NASA's Jet Propulsion Laboratory in Pasadena, California, says the rover's in excellent condition to undertake the rim climb challenge. He says mission managers are raring to see what's up there. 2 of the priority regions the science team want to study at the top of the crater are nicknamed Pico Tequino and Witch Hazel Hill. Imagery from NASA's orbiters around Mars indicate that Pico Tequino contains ancient fractures that may have been caused by hydrothermal activity in the distant past. Meanwhile, orbital views of Witch Hazel Hill show layered materials that likely date from the time when Mars had a very different climate than what it has today. Those views have revealed light-toned bedrock very similar to what was found at Bright Angel, the area where Perseverance recently discovered and sampled the Schiappa Falls rock, which exhibits chemical signatures and structures that could possibly have been formed by life billions of years ago when the region contained running water. Back during the river delta phase of the mission, the rover collected the only sedimentary rock samples ever taken from a planet other than Earth. Sedimentary rocks are important because they form when particles of various sizes are transported by water and then deposited into a standing body of water. On Earth, liquid water is one of the most important requirements for life as we know it. A study published in the Journal of the American Geophysical Union Advances chronicles the 10 rock core samples gathered from sedimentary rocks in the ancient Martian River Delta, a fan-shaped collection of rocks and sediment that formed billions of years ago at the convergence of a river and the crater lake. The core samples collected at the fan front are the oldest, whereas rocks caught at the fan top are likely the youngest, produced when flowing water deposits sediment into the western fan. Among these rock cores are likely the oldest materials sampled from any known environment that was likely potentially habitable. Now, if they're eventually brought back to Earth by the long-proposed joint NASA-ESA Mars Sample Return mission, they'll tell scientists about when, why, and for how long Mars contained liquid water, and whether some organic, prebiotic, or even potentially biological evolution may have taken place on the red planet. As for the Crater Rim mission, well, it promises to provide samples that will have significant implications for understanding Martian geological history. That's because these are expected to be samples of the red planet's most ancient crust. The rocks formed from a wealth of different processes, and some represent potentially habitable environments that have never been examined up close before. But reaching the top of the crater's rim won't be easy. To get there, Perseverance will have to rely on its auto-navigation capabilities as it follows a route that the rover's planners back on Earth designed to minimize hazards while still giving the science team plenty of stuff to investigate. Encountering slopes of up to 23 degrees on the journey, the rover will have gained about 300 meters in elevation by the time it summits the crater's rim, at a location which the science team have now dubbed Aurora Park. Then, perched hundreds of meters above the 45-kilometer-wide crater floor, Perseverance can begin the next leg of its adventure. The rover will characterize the planet's geology and its past climate to help pave the way for future human exploration of the red planet sometime during the next decade. This is SpaceTime. Still to come, we have a full moon tomorrow night, and not only will it be a supermoon, it'll also be a blue moon. We'll have all the details next. And later in the science report, there are new warnings today that the Mpox virus is now starting to spread beyond Africa to the rest of the world. All that and more still to come on SpaceTime. If you look into the sky tonight, you'll see a full moon. A full moon usually lasts for about 3 days before the shadow of the Earth starts to bite into it again. The moon will actually reach its fullest early tomorrow morning, and not only will it be a perigee or so-called supermoon, it's also a blue moon, and it doesn't end there. It's sometimes called a sturgeon moon, the red moon, the corn moon, the green corn moon, the barley moon, the herb moon, the grain moon, and the dog moon, depending on your preferences and cultural beliefs. To be precise, the full moon will occur at 4:25 a.m. tomorrow, August the 20th, Australian Eastern Standard Time. The term supermoon is a trendy name beloved by old-school media looking for clickbait to describe a perigee full moon. That's when the moon's at its closest orbital position to the Earth during a full moon. Now, on average, the moon orbits about 384,400 kilometers from the Earth. But the moon's orbit around Earth isn't a perfect circle. It's slightly elliptical. That means one part of the orbit will be an itsy-bitsy bit closer to the Earth, about 357,000 kilometers away. That's known as perigee, while the other part of the orbit will be a bit further away, around 406,000 kilometers. That's called apogee. The difference in orbit is about 5% closer or further away than the average. Now, the exact distances at both perigee and apogee also vary due to other factors, such as whether the lunar orbit's long axis is pointed towards the Sun. Also, the moon's orbital extremes are at their greatest between November and February. That's when Earth's orbit places our planet, and therefore the moon, closer to the Sun. You see, Earth's orbit itself is also elliptical by almost 2%, and therefore the Sun's gravitational influence is greatest during those months. Now, while people tend to make a big deal about supermoons, they're actually not all that uncommon, generally occurring in groups of about 3, roughly every 13 months and 8 days. Now, that means every 14th full moon will be a supermoon. Now, while technically a supermoon can look about 14% larger and 30% brighter than a normal full moon, you really wouldn't notice the difference unless someone told you. And even then, any size difference perceptions you do have would more likely be due to your imagination. Even skilled sky gazers are challenged to see any real difference in size or brightness. In reality, you'd really need proper astronomical equipment to measure the difference. Also, remember that the full moon always looks unusually large and bright when it's near the horizon. That's an effect known as moon illusion. One consequence of perigee full moons, and new moons for that matter, might be a noticeable increase in ocean tides. There are many factors influencing tidal heights at given locations, though they're usually highest, known as spring tides, at the full or new moon when the sun, earth and moon are all aligned. So, a perigee moon being a bit closer than the average will result in slightly higher tides. The term supermoon isn't that old. In fact, it was first invented just in 1979, not by an astronomer, but by an astrologer. Now, for those unfamiliar with the difference between the two, and I'm quite sure no one listening to this show fits in that category, nevertheless, an astronomer is a person who studies space and the cosmos using the scientific method to learn more about the universe. On the other hand, an astrologer is a pseudoscientific person who uses inaccurate positions for constellations, planets and other celestial bodies at different times to tell others about their character or to predict their future. There has never been any scientific evidence supporting any of the claims made by astrology, and its continued success in society depends exclusively on people's gullibility. These days, trendoids use the term supermoon, and I saw it in an article just earlier today to describe any full moon within 90% of perigee. And for the record, this will be the first of 4 consecutive supermoons this year, with the full moons in September and October being the closest. Although it won't look blue, as the third full moon in a season with 4 full moons, this is also classified as a blue moon. The first recorded use of the term blue moon in English dates back to 1528. Speculation as to the origin behind the term include an Old English phrase that means betrayer moon because it led to mistakes in setting the dates for Lent and Easter. But since the 1940s, the term blue moon has been used to describe a second full moon in a calendar month that has 2 full moons. And the names don't end there. The Maine Farmer's Almanac began publishing Indian names for full moons back in the 1930s, and these have now become widely known and used. Now, according to this almanac, for a full moon in August, the Algonquin tribes in what is now the northeastern United States called this the sturgeon moon, after the large fish that were more easily caught at this time of the year in the Great Lakes and other major bodies of water. But other names reported for the moon is the red moon, the corn or green corn moon, the barley moon, the herb moon, the grain moon, and even the dog moon. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization has declared an upsurge of Mpox cases across multiple African countries a public health emergency of international concern as the virus begins spreading to the rest of the world. The disease, formerly known as monkeypox, spread rapidly across the world in 2022, including Australia, and it's now surging again with a new variant. Mpox is a viral disease caused by the orthopox virus. It was first identified in humans in the Democratic Republic of Congo in 1970 and is endemic to Central and Western Africa. Mpox can be transmitted from animals to humans and between humans through direct contact with skin lesions, body fluids, or the respiratory droplets of an infected person. It can also be transmitted by prolonged face-to-face contact with an infected person and touching contaminated objects. Historically, Mpox was neglected in Africa, but it gained global attention during a 2022 outbreak that spread to regions like Europe, Australia and the United States. The current outbreak is concerning due to a new strain known as Clade 1b, which is spreading rapidly in the Congo and at least 12 neighbouring countries. Importantly, this strain is potentially more deadly and it appears to affect children at a higher rate than other strains. A new study has found that Australians are more likely to live longer than people living in New Zealand, the United States, the United Kingdom, Canada or Ireland. The findings, reported in the British Medical Journal, are based on data from the 5 English-speaking countries to see how life expectancy differs among culturally similar nations. They found Australia was a clear best performer in terms of life expectancy, leading the rest by 1.26 to 3.95 years for women and 0.97 to 4.88 years for men. Now, the study can't explain why other countries with very similar lifestyles to Australia differ in life expectancy by so much. However, researchers are speculating that Australia's high number of migrants and where they come from may be playing a role. Australia has lower life expectancy inequality. However, this may in part be due to its very small Indigenous population, as the life expectancy gap between non-Indigenous Australians and Aboriginal and Torres Strait Islander people remains high. Differences in lifestyle also play a significant role, and the researchers say the death rates from drug and alcohol misuse, screenable and treatable cancers, and cardiovascular and respiratory diseases are all lower in the true blue land of Oz. A new study has shown that increasing coastal erosion is reducing the Arctic Ocean's ability to absorb carbon dioxide. The findings, reported in the journal Nature Climate Change, are based on new computer modelling. The projections found that the annual increase in atmospheric carbon dioxide due to permafrost erosion by 2100 may be the equivalent of about 10% of European car emissions in 2021. The authors warn that the Arctic is now warming 4 times faster than the rest of the planet. The thawing Arctic permafrost is allowing for faster coastal erosion in the region, which is projected to increase by a factor of 2 to 3 by the year 2100. And that will increase the supply of organic matter from land into the ocean. According to the modelling, previous climate studies may have misinterpreted the Arctic Ocean's uptake of carbon dioxide from the atmosphere by not including the areas worst affected by coastal erosion, which release more carbon than they absorb. The Chiropractic Board of Australia has been forced to reinstate a ban on the dangerous practice of spinal manipulation of infants, or commonly known as baby back cracking. The reinstatement follows an outcry by doctors and a request from health ministers who have been asked to formally outlaw the practice. Chiropractors claim spinal manipulation of babies helps with colic reflux constipation and different problems with sleep. But Tim Mendham from Australian Skeptics points out that the Royal Australian College of General Practitioners has found little evidence supporting these so-called benefits and believe the treatment is simply unsuitable for young children.
Chiropractors have been sort of cracking people's backs for a fair time. It's probably over 100 years now. And one of the issues that cropped up was cracking the backs of infants. I mean, infants like week-old or weeks-old babies. Their skeleton is still forming in a way. They're very vulnerable to things that might happen. And I've seen quite horrifying videos of a chiropractor either raising a baby by the feet or putting it over their lap and cracking the spine. And it really is a crack sound. And it's one of the most horrifying things you can see. We can do major damage. It can do damage to adults, especially when they're twisting the neck and twisting the head. With the babies, it tends to just be cracking the spine rather than twisting head. You wouldn't want to do that to a baby. And when various videos came out of this a number of years ago, about 4 years ago, there was an outrage, understandably. One of the main chiropractors who was doing this was called in front of the chiropractic board and they waved their finger at him and said, "Don't do that again, and you can no longer treat anyone under 12. So they banned the practice for a while. And then recently, they unbanned the practice and said, it's okay now, you can go back to cracking babies. And then there was an outrage by the medical fraternity, etc., saying, what the hell are you doing? These are babies, do not do this. So they banned it again. This is the Chiropractic Association doing this. So the Chiropractic Board of Australia, it's a different thing. Chiropractic Board banned this process. So they banned it, unbanned it, banned it again, and now the Chiropractic Association, which is almost like a trade union of chiropractors, is demanding it be opened again. So the whole issue is that the chiropractors are claiming it's a very specific adjustment tailored to the force appropriate to the size of the person who's receiving it. You're talking about babies, it's not little tiny forces. You can hear a baby's back crack. It's dangerous, and you could do something very serious to a child that they'll suffer from the rest of their life. Apart from the fact there's a lot of stuff within chiropractic which is totally unsupported by science, including some of the technology and terminology that they use themselves, as in a subluxation, which is, no one really knows what it is, but it's a thing which is quoted a lot in the chiropractic fraternity as the cause of the spine being out of order and all these sort of issues and illnesses being generated forthwith. Chiropractic is lower back massage. Should be stick with that. Get out of the thing where it causes every illness known to mankind.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.